Told you, videos all week, so we're ready to go for some more videos, getting ready for a little math action. But before we get started, of course, you know, some of the teacher of the universe, the Algebra 1 champ, the middle school math champ, gotta do a little bit of fun stuff first. So, open up some things first. Found get some hockey mates. The hope is here, of course, we get some Lightning players because they're the only team that matters. Let's see. The Canes, that's okay. You can hang out, I guess. We'll let you hang behind QB back there. And a Boston, the Bruins. You can't hang out. I don't think so. Sorry. All right, again, some baseball players. You got some lockers. You got You've got a full out locker ready to go with the Gatorade bottle, Gatorade jug sitting up here. Let's see what we got. Again, beginning Astros players, of course, just like the Bruins guys, we throw them away. Oh no, we're good. We're set. We got Kikuchi, sure. Mariner pitcher, I do know that part. Kettle Marte, Miggy Cabrera. I mean, some good players there, and of course, no Astros. Even better. It would be better if it had been a Rays player or a Braves player, but I mean, you know, I guess beggars can't be choosers. They can sit up there. Oh, you can go away. Oh, we got one more thing. Harry Potter bag. See, last time we did a Harry Potter thing, I didn't know what it was. Dane, again, thank you for helping me out with the mermaid being from the fourth movie. Yeah, that's right. So let's see. This is an easier one. See, we only can get like Harry Potter or the main characters, which means I'll know what it is. Oh, sweet. Look at that. Harry Potter running around, ready to go with a wand in hand. You can hang out with Jorge Alfaro out here. Sweet. How you did that? Oh, got some Disney pins for today, of course. We got Mickey inside of a Mickey hand. 4 fingers, of course, because it's easier to draw than 5. Looks like Anna riding around a Skyliner, which means she's probably getting stuck, because that's what happens with the Skyliner. And a Jiminy Cricket Mobile. Sure, why not? Some good Disney pins for today. And of course, time for quotes. Throwback quote. Mirrors can't talk back, or can't talk. Luckily for you, they can't laugh either. See, that's funny, because it's mean. All right, and today's quote of the day. Life is not a fairy tale. If you lose your shoe at midnight, you're drunk. Well, hopefully none of you are. Obviously, you're middle schoolers. Clearly not doing that. But if somebody you know, an older cousin, college age, 21 and up, of course, loses their shoe, bad things could happen. You don't want to try and be Cinderella. All right. So we're going to let this thing up here, of course. Oh, what have we done? Well, of course, you know what time it is. It's time to do a little math. Let's go to the board. All right, now, Happy, Chubbs, Otto, pay attention. This is going to be on the quiz. We're back. Ready to go, algebra guys. First, a little bit of solving systems of linear equations. Today we're doing elimination part 1. Why part 1? Because we're going to do part 2 later on. Otherwise, it'd be stupid. Why would we call it part 1 if there was only one part? Anyways, we're here. We're going to do a little bit of the elimination method. Now, why would we use the elimination method for solving a system of equations? Well, generally, if we have equations like this, where we are lined up in the same format, and we've got coefficients that are the same or opposites, and it's always a good time to use the elimination method. So that's what we're looking at today. So for example, we have negative 4x plus 5y equals 14, negative 3x minus 5y equals negative 7. We want to find the solution to this system of equations. We want to find the one ordered pair, the x and y value, right? That will... Somebody keeps bringing this red marker in here. It's killing me. I don't know who it is, but they're clearly going to be fired. Let's try to use this one. Does work, I'm pretty sure. We're going to add the equations together here, because if I add these equations together, negative 4x plus negative 3x is negative 7x. That's easy enough. 5y plus negative 5y equals 0y, which is perfect, because that means we end up producing an equation with just one variable. We can solve that. Add here, we get 7. So now, negative 7x equals 7. Divide by our coefficient. X equals negative 1. That's halfway there for our solution. That's halfway because, of course, I take this and plug it into one of the two equations. Does it matter which one we choose? Think back, think back, think. Of course not. But I'm going to use the first equation. So I'm going to plug in negative 1 for x. So we get negative 4 times negative 1 plus 5y equals 14. Negative 4 times negative 1, positive 4, plus 5y equals 14. Subtract 4 from each side. Five y equals 10. Divide by 5. Y equals 2. There's our solution to that equation. Now we can plug these in to our other equation here just to be sure, just to verify it real quick. So negative 3 times negative 1 minus 5 times 2 equals negative 7. Well, negative 3 times negative 1 is positive 3 minus 10 is negative 7. Yeah, negative 7 does equal negative 7. Fantastic. That means our solution worked. Great. That's what happens when we add the equations together. But what about a situation like over here? Let's move over ever so slightly. 5x plus 6y equals 50. Negative x plus 6y equals 26. Well, I've got the exact same coefficient in front of y. If I were to add these equations together, that wouldn't help me. 6 plus 6 doesn't equal 0, it equals 12. What I could do is subtract the equations. I'll subtract the whole equation. Now, most people don't like subtraction, given the choice. So what I'm going to do is use my favorite property, your favorite property, say it with me. The whole distributive property, I'm going to distribute that negative into the parentheses here. Or, in essence, change every time I make this addition. If I do that, I end up at 6x plus 0y equals 24. Divide by 6, x equals 4. We're halfway to our solution. Now we're going to pick either equation we started with. I'm going to use the first one again. 5 times the value of x, which is 4, plus 6y equals 50. 20 plus 6y equals 50. Subtract 20 from both sides. 6y is going to equal 30. Divide by 6. Y equals 5. And now we've got our solution. Again, we got our solution to this system of equations. We're using the elimination method for solving the system. And again, it's called elimination because we're eliminating a variable when we either add or subtract the equations together. Seems like a pretty good introduction. We're going to do one more problem, like a word problem again. I know we did one yesterday, 2 in a row. It's crazy. But we'll do one word problem, then we'll be done for the day. We'll see you back in just a second. As always, special shout out to these guys right here, coming in every day, learning a little math with you and with me. The siblings, Anthony, Ross, Rebecca, and Nelson. Oh, so happy to see y'all again. As always, hope you enjoyed the math. We're back, ready for a word problem. Right here we got a rectangle. Well, it's in the back. Simba, shut up. It's not nice to make fun of my inability to draw. It's just rude. COVID Mickey, COVID Minnie, tell him what's up. Cough on him if you have to. Just kidding, don't cough on people. That's terrible. Again, we have a rectangle. The rectangle has a perimeter of 14 feet. Twice the length of the rectangle is equal to 1 less than 4 times its width. We need to find the length and the width of the rectangle. Well, just with first sentence, knowing that perimeter is 14 feet means that we actually can come up with one equation pretty easily for this. We know that for perimeter of a rectangle, 2 times the length plus 2 times the width equals the perimeter. That's a good start. We also know, I think to our second sentence here, twice the length of the rectangle, 2L, is equal to 1 less than 4 times the width. So now we got a system of equations here. You can actually work this out now. I'm going to rewrite the second equation. So I've got 2L minus 4W equals -1. So that I've got two equations now written in the same format. So 2L plus 2W equals 14. 2L minus 4W equals -1. Now I've got a system. I've got the same coefficient for one of the variables. Since it's the same, and we've got the same sign, I'm going to subtract these equations from each other. All right, which means we're going to use our old distributive property, distribute in that negative. That cancels out. We get 6W equals 15. Divide by 6. 15 divided by 6, that's not going to be an integer, but it is 2.5. So our width is 2.5 feet. Now that we know that piece of information, which is pretty handy, I'd say, we can use it to plug into either of our other equations and solve for L. So take this right there. 2L equals 4 times our width, which is 2.5, minus 1. 4 times 2.5, that's 10. 10 minus 1 is 9, so 2L equals 9. Divide by 2. L equals 4.5 feet. Boom. Now just make sure, just think about our perimeter is 14, which means 2 of our lengths plus 2 of our widths should equal 14 feet. Well, 2 of the lengths is going to be 9 feet. 2 of the width will be 5, and 9 plus 5 is 14. How about that? Don't you love it when the math works out? That's why these are mine. We'll be right back and close it out in just a second. Enjoy this math.
Half hours later.
All right, closing out another great day of algebra. Ready to go again. Of course, don't forget, guys, if you're struggling with Edgenuity, struggling with any of the stuff we're working on, you got to contact me. I'm not able to use the whole ESPN. We're going to stick with that to figure out what's in your heads. So again, let me know if you're needing retakes on stuff. You've got to let me know what section, and you got to send me your notes. Of course, we're not doing it all for free here. Anyway, we'll see you back tomorrow with a little more math. Part 2 of Elimination coming up. Till then, have a great day. We'll see you later.